our first speaker today is Johnny. He's an industry analyst from India, and we'll kick it off with him and then jump into Amanda's segment after. So Johnny, go ahead and let's get you rolling.
Thanks, Connie. Let me share my screen and let me start off with elicitation. So
Great.
I'm assuming all the viewers are familiar with MCP protocols, but the most recent update that took place on 18 June came out with a very interesting new feature called elicitation. It's a part of the new spec, not implemented yet. It's currently in draft. But what this basically brings is the ability to bring human into the loop. So typically, when we use an MCP server and an MCP client, we pass the parameters directly to the tool, but there may be some interactions or some scenarios where we may have to prompt the user and get their input. For example, you are implementing an expense management tool and you want to send the approval over Slack to the manager and wait for him to come back. So the manager will take a look at the expense statement. He will verify the bills if he wants to, and then he'll approve it. And once the approval is done, the MCP tool will resume and it will process the rest of the tool or the workflow. So if that is the scenario, till date, MCP didn't have the ability to put the human in the loop. But with the user interaction model and elicitation, there is a opportunity, there is a chance for us to bring user into the overall flow. So this is how it works. We basically have the client initiate a session and then register its elicitation callback. And when the server has to elicit input, it will send it to the client and client will present it to the user. This is completely agnostic. It could be a console, simple prompt input, or it could be Slack, Microsoft Teams, or WhatsApp. It doesn't really matter, but you can basically escalate this message all the way to the user interface and wait for the user to interact with it. So this is dynamic mechanism of accepting the parameters instead of hardwiring them and sending it directly to the server from the client. So one of the very important aspects of elicitation is the streamable HTTP protocol. If we don't understand how streamable HTTP works, then it is very hard for us to understand how elicitation works. So I'm going to first show you the streamable HTTP workflow back and forth between the client and server. And then I will actually implement an elicitation and show you how it works. So let me start with my first demo, which is the streamable HTTP and dissecting the entire flow. So I have a very simple MCP server and client. So here is my MCP server. It basically has a list of dictionaries. So it sends fictitious employee names and the roles. That is the tool that I'm implementing. And I'm implementing HTTP, which is Streamable HTTP protocol instead of STDIO. By the way, elicitations work with STDIO, but it's far more transparent and far more easier to understand if you look at the Streamable HTTP protocol, the transport protocol instead of STDIO. So this is my most simplified MCP server, and then I have the MCP client, and this MCP client talks to Gemini, the multimodal AI model from Google. So here I basically send a prompt that says who is the intern in the company, and we expect Eve to come back as the intern, which is a part of the tool workflow. So this is an end-to-end example where we have three actors: the LLM, which is Gemini, the MCP client, which is what you're looking at, and then the MCP server. So let me first show you what happens when we actually use Streamable HTTP as a protocol and make this. At this point, we are not talking about elicitation yet, but I'm currently focused more on understanding how Streamable HTTP works and why it becomes the foundation or the building block for elicitation. So let me start with that. I want to introduce a tool, which is one of my favorite tools. This is called HTTP Toolkit. It's available for Mac, both Apple Silicon and Intel. And the free version is good enough to basically intercept the traffic that goes back and forth, particularly when you're using localhost. So I'm going to start this. So I have just two files, the MCP client and MCP server. So first I'm going to start the MCP server. And now I'm going to invoke the MCP client. Now, the moment we invoke the MCP client, we see a lot of things happening on the screen. There are multiple post requests. There is one get request, and then there is one delete. Now, what exactly does this mean? And why is the client making so many calls to the Streamable HTTP endpoint, which is /MCP? The first demo is about understanding this. So what I'm going to do is I will show you the HTTP toolkit intercepted output. So the first post that takes place between the client and server, let's look at the request. So the request is initialize. This is the JSON RPC request that goes from the client to the server, and server comes back with what is called as the MCP session ID. Now, this is the very first call made from the client to the server. And this is to initialize the conversation. Once the initialization is done, the session is established and we see the session ID coming back. And this is the complete context, or rather the identifier between this entire conversation that takes place between the client and server. So once the session handshake is done, then comes the event handshake. Remember, Streamable HTTP is about two-way communication. It is not just like, it's not stateless, it is stateful. And it is not like REST where you fire and forget. Here you basically establish a stateful connection between the client and server. So the next one is the initialization of notifications. So here we basically send the request with the same MCP session ID that was returned from the first handshake, and then we initialize the notifications. And this is a HTTP 202 accepted response, which means this is now registered. And then finally, to close this conversation, there is a get request from the client to the server again. And this establishes the channel between the client and server. So this is the content type of text event stream. And this get request ensures that any events that are lined up and scheduled by the server are sent to the client. So that is the reason why the client makes a get request. And that completes the handshake of initializing the session, the notifications, and the channel to receive server-side events, server-sent events. And then the actual work starts. The next step is to discover the available tools. So the client makes a call to this endpoint, which is tool/list. And then the response is the tool. Now, in our case, we have one tool called get employees. It comes back with that. So now the client knows that there is a tool called get employees. Now we send that to Gemini. So Gemini natively supports MCP. So in the tools parameter, I pass the session that I have established with the server. Now, Gemini knows that it can invoke the tool. So this information is passed along the prompt to the Gemini model. So the prompt here is who is the intern in the company, and the function name that is being sent is get employees. So this is simple tool calling. The only difference is it's not a embedded tool. It is coming from the server, and this get employees information came from the previous call that we saw here. So now Gemini understands that, okay, we are asking about the intern and there is a function called get employees. It comes back and then it invokes the actual tool. So this time there is a tool call method, and we are invoking get employees. This is initiated by Gemini natively. And now you see that there is a JSON RPC response with all the employees coming back. This is basically the JSON packet. Now, this entire information is sent back to Gemini, and you see that it is formatted both as structured content and as plain text. This goes to Gemini, and now Gemini is well informed about finding out who is the intern in the company, and it comes back with Eve is the intern in the company. So that concludes the entire round trip and the entire workflow. And finally, because this session is done, the client calls delete, and this disconnects the client from the server sent events and also the MCP session. And this completely gets ready for the next invocation. Now, every time you invoke an MCP server from the client using Streamable HTTP protocol, this is exactly the steps that it follows. Every session is re-established and this entire flow takes place. Now, why is this important for elicitation? Well, elicitation uses the server sent events mechanism for the server to push a prompt or a user input text in a very structured format, of course in JSON, to the client, and the client uses that to render. For example, it could be a pop-up dialog, it could be a WhatsApp message, it could be a Slack message. It's completely up to the developer on how he surfaces this prompt that is eliciting the user interface or the user interaction into the UI, into the user interface. And that happens because of Streamable HTTP mechanism. So this is actually where the server pushes the notification to the client and it comes back as structured JSON. Now, at a high level, some of the libraries like Fast MCP give us the flexibility of mapping the JSON packet and the JSON structured data structure into a native data type, a Python data type, something like a list or a dictionary or anything that you prefer, or even simple data types like string, integer, and so on. So let me show you the next demo where we implement a very simple elicitation. And this is the code for that. So I'm using Python with Fast MCP. I call this as the elicitation server. And I define what is called as data class. Now, data class comes from the Fast MCP library. No, actually, it is a part of the Python base library. So here we implement user info, and we call this as str and int, which are the data types. And this is going to be serialized into a JSON packet at runtime. And we have a tool which is called collect user info. Now, collect user info is not your usual tool because it is going to prompt the user to provide his name and his age. And it is going to return, hello username, you are X years old. If I want, I can cancel it as a user. I can decline to provide any input, or I can cancel the operation. Now, all of that will go back to the server, and the server can make an informed decision on how to deal with it. Now, in my case, it's a simple if-elif condition. Now, this is how I write my elicitation in the server. In the client, I have a callback handler. So here, this event, the elicitation event, is going to invoke this handler. And here I have a simple Python input method to grab the input from the user, your name, your age, and then I send the response type as simple scalar data types like name and age. So very straightforward. Now, how do I register the elicitation callback handler? Well, when I am initializing the client, I explicitly register the elicitation handler. So because of this, the server comes to know that it has to invoke this specific method. You can call it anything, but as long as it actually carries the same signature like message, which is string. Now this is the message that we defined here. Please provide your information. This comes to the callback event as the message. Response type is the data type. Now that's what we defined here. User info, which has name and age, and the parameters, which are the name and age that come as separate inputs, or as one data type, custom data type if you prefer. And then there is context. We don't use it, but context will give us an opportunity to manipulate the packet as it flows back and forth. So that is how we define the communication between the server and client. So let's go ahead and run this, and I'm going to clear the interception log. Okay, and start all over again. So let me stop this and go to demo 2. Okay, so I launch my server. I have just 2 Python files here. So I'm going to launch the server, and I'm going to launch the client, and then I come back to my HTTP toolkit. Oops. Okay, now something very interesting takes place. Now you see these rotating dots. It is an asynchronous call, and the callback handler has kicked in, and it is waiting for the input. Now the first post, the session initializer, then the notification initializer, and then the get, which is basically meant for the events, and then there is a post. So all of these are exactly the same. The only difference is right after this get, it is waiting for the user input. So I'm going to input John Doe 22, and the server comes back with structured content that says result is hello John Doe, you are 22 years old. And then if you look at the workflow, it's exactly the same. The only difference is because of the server sent events, we receive the event and we wait upon the user to provide the input, and then everything else follows the same. So that is one end-to-end session with the elicitation in place. So now you understand why the Streamable HTTP plays a crucial role in enabling this capability. You can all, of course, do it with stdio, but it's very hard to break it down into the exact workflow. If you're using stdio, it becomes almost like an RPC call between the client and server, and you cannot intercept this with so much of transparency and clarity. So that's why I chose Streamable HTTP. But you can do this with stdio as well. And not every MCP client implements the elicitation feature because it is currently in draft. It is going to make it to the final, and then most of the clients will get updated. Currently, the native LLM clients that support MCP may or may not support elicitation because it's in the draft form of the spec. So now I want to show you more of a real world demo. So that is my third demo. And what I want to do here is show you the code first and then launch. So I want to basically write an LLM chatbot that accepts the flight information, like my flight number, and tells me the current status, whether it is delayed or scheduled or landed or en route. So it's more realistic because we need to ask for the flight number from the user. So let's take a look at the server first. Now I use an API which is called flight aware. That is not really important here. You can implement this logic the way you want it. But what I want to point is this is real time. I'm using real APIs to pull the flight information. And my data structure here is just a string. I could have avoided this and just send the string directly, but this is more of a best practice. Even if you are sending just one string back and forth, it is still a good idea to use data class because this will ensure that the MCP infrastructure is serializing the right way. And then we define a tool called get flight status. And the prompt that we send, the message that we send to the end user is please provide the flight number you want to check. And response type is flight info, which is this. And then I can decline, cancel, or accept depending on the UX element I'm dealing with. And then the flight number, I have I have a variable here where I capture, and then I continue with the asynchronous method of getting the flight status. And I also convert the time zone to the local time zone where the flight is landing. So there are some helper functions, not very important, but the ultimate goal is to get the real-time flight info by sending an elicitation to the user and get the flight number. Now, if you don't use elicitation, this flight number has to come as a parameter to the tool directly, where you can still ask the user, but it is not as elegant as this. Now, the beauty of using elicitation between MCP server and client is it is completely dynamic. We don't know whether the server is going to ask just a string or string plus an int or a complex data type. We don't know. Now, that can be found out here, that can be derived at runtime, and you can basically figure out a way to either render it dynamically or to show the most appropriate UX element and build a nice UI that lets the user select the input for the elicitation. So that was the server. Now, when it comes to client, since Gemini client, LLM client is not aware of elicitation, I am creating a helper function called send to Gemini. And this basically accepts the context, which is the complete flight data. And it also accepts the prompt, whatever I ask, like when is my flight landing and all of that. It sends the entire context to Gemini and comes back. But remaining, it's almost the same. We have an elicitation handler, which is meant for callback. And we register it along with the MCP server. And then I have a very simple UI to either invoke the tool directly or through LLM and exit. So let me execute this. I'll clear the logs, the interception logs, and I will launch the server and client again. Should be server. Okay. And then comes the client. Now, as soon as I execute the client, I have a very simple menu. Now, I can invoke the tool directly without involving an LLM. So I'm going to ask the status of one of my most frequently flown flight called EK226, that is San Francisco to Dubai, which is one of my favorite flights. So it comes back and prints the output. So it is currently diverted. Wow. It is supposed to be landing in Dubai at 7:30. So on 31st, but it is currently diverted. Not a good sign. So this is working. Now, when we look at the logs, again, exactly the same workflow. To post first and then a get. We haven't deleted because the session is still active. Now, what I'm going to do is I will involve the LLM and I will invoke the same tool with elicitation and send the entire context to Gemini. So here it is asking me the flight. So when is the flight landing? Now, I don't give any other information because I know the UI is going to prompt me. So I'll enter EK226 and it's sending to Gemini. It comes back. The flight was scheduled to arrive. However, the flight status is diverted, which means it will not land at the originally scheduled time or destination. So now this analysis and this extra info is provided by Gemini. Now, when we look at the entire call chain, we notice that we are invoking Gemini, and if you see, it completely has the context. So the key takeaway is elicitations are built on the capability of eventing, which is delivered via server-sent events and streamable HTTP. You can prompt the user at runtime, get his input. This is a great mechanism to put human in the loop. And we have seen some demos where we could elicit the user input by prompting them at runtime, and the client doesn't know, the server doesn't know, it happens completely at runtime. So that's the beauty of elicitation and the ability to bring human into the loop. So that concludes my demo.
Great. Thank you, Johnny.
That was great. I love the detail on how all that works. Demystifying it to a certain degree. There's so much, there's so many things going on in MCP to make this all happen. I mean, I think what I was kind of curious your thoughts on there's been some discussion with elicitations around kind of like private or sensitive information and whether or not that should be handled or how it might be handled going forward.
Yeah, so the spec very clearly calls out don't accept passwords, usernames, and sensitive information. There is no enforcement at this point. It doesn't really check what you are eliciting from the user. But the best practice is you should not really share sensitive information, because some MCP endpoints may not even implement HTTPS, forget about OAuth. So your data is going to be flowing in plain text. So read the spec. That's the feedback I have for everyone watching this. There are some do's and don'ts. And one of the very important don't is not to use sensitive data in elicitation, because there is no guarantee that it is being encrypted. So that is something that you need to be aware of.
Yeah. And one thing is, like, I think the very latest specification, it did land in the specification, right? So it is actually part of the latest MCP specification.
I need to cross check. The last I checked, it is still under draft. Maybe it made its way. Things are moving so fast that by the time I finish the demo, there will be an update.
Yeah, so I think it did because when they released the new, they released the new spec and then they immediately copied over to draft. So we'll see the draft. I'm pretty sure it landed in the last one. I was very early on elicitations. I was kind of implementing it before it even, they finalized or whatever. But I think it's kind of an essential feature. I'm really excited to see the kind of enhanced interactability about MCP. I think there's really a lot of interesting aspects about it where I think it's going to turn into quite an interesting application platform. How do we build these AI applications? So
right.
Thanks. That was really good. I loved all the technical details.
Cool. Thank you.